Thanks for everybody, and welcome back to today's video lesson. Well, before I proceed any further, I would like to quickly recall the topics of the last week's video lesson. Those were the sorting techniques with regard to the unsorted list. There were three methods. The first one is the selection sort, and then we have the bubble sort, and then finally we have the insertion sort. So just a matter of a fact, I would like to once again request everybody to be completely thorough with the algorithm or the logic behind the program. Okay, so the programming tasks will be much easier. Well, for today's session, I would like to continue further, and the topic for today is the list comprehensions. So this topic is relatively easy. I'll be coming up with various examples. Now let's say example number 1. Now before I tell you anything about the very definition of the list comprehension, I'll come up with the example and then you'll be able to understand the definition better. Let's say we have a list in which I have elements like 2, 4, 6, 8 and 10. So this is understandably one way to create a list, assigning the values directly to the list. There could be another way. If I could use the list creating for loop along with the functions or the features like the append or the extent, which you have learned in class 11. So if I could replicate the same thing via for list create for loop, it will be something like this. Now this is the first way to assign the values directly, and then another way out could be something like this. Let's first define an empty list, and then we'll use the for loop for I in range and then 1, 6. Okay, so the numbers in period are 1 to 5, and then if I could multiply the individual numbers by 2, I will get the content of the list. Okay, so this is quite straightforward. So I'll have list, and then I'll use the function by the name of append, in which I multiply the individual values of I by 2. Okay, so this is again yet another way of creating a list in which you'll have values like 2, 4, 6, 8 and 10. So this is self-explanatory. The first value of I will be 1, 1 times 2, 2 will be appended, and then the next value of I will be 2, 2 times 2 will be 4. This is how the list keeps getting populated with the required values of 2, 4, 6, 8 and 10. Now the crux of today's session is to simplify the list creating for loop. Now this is what we mean by list creating for loop. I'm using a for loop by which I'm creating the list. Alright, so the list comprehension is a concise description of a list which provides us with a shortcut method to create a list which could be summed up in a form of a single statement. Okay, so that's what we refer to as list comprehension. So alternatively, I could use the list comprehension like this: list equals, and then I'll have the square bracket. So the first part of the list comprehension will always be the expression which is used to create the list. So clearly we could see that this is the very expression which is used to create the list. So the first thing that comes in the list comprehension is the expression creating the list. I won't write it, it's pretty simple. So first thing that you're going to see will be I multiplied by 2. Okay, and then you will have the for loop, for I in range, and then you have 1 comma 6. Okay, so and then you have the square bracket. So this is the expression for creating the loop, for creating the list, sorry, and then this is the very loop, which is iterable on certain object. As of now, it's nothing but range. You could have the list tuple, or for that matter, any other object, right? So this is nothing but a substitute or an alternative for the list creating for loop. Okay, so this is the list comprehension way by which I could create the list. So you need to keep this thing in your mind. The first thing that comes in the list comprehension is the expression which is used for creating the list, and then followed by the for loop, which is iterable on a certain object. It could be range or it could be any other objects, right? So this is the example number 1. So this is what we mean by list comprehension. It provides a concise way of describing the list, which provides a shorthand for creating the list using the for loop. Okay, so basically it's nothing but it provides a mean of a shortcut way or a shorthand way in which we could create a list which uses the for loop. Let's take another example. Now this time I would like to take an example, say using the if condition. Okay, I'll be demonstrating one example which will have just if condition. Say the programming task is printing multiples of 3 till 50. Okay, so I just would like to print all the multiples of 3 in the range of 1 to 50. So before we write the same task with the list comprehension, we'll come up with a conventional method so that you'll be able to weigh the importance. Say generally, we first come up with an empty list, and then these are quite straightforward, right? And then for I in range, alright, and then you will have 1 comma 51 in order to include 50 in the range, even though 50 is not a multiple of 3. And then I have the if condition. If I modulus 3 is equal to 0. Upon dividing I by 3, if the remainder is equal to 0, then the value of I is indeed a multiple of 3. This is something which you have learned already. So if the condition is true, I would like to append the value of I in the list. Okay, so this is how I use the list creating for loop. This is nothing but list creating for loop in creating a list in which the elements are nothing but the multiples of 3 till 50, right? So the idea is if I could replicate the same task using the list comprehension, it's going to be like this. List equals, and then you will have the square bracket, and then first thing that comes in the list comprehension is the expression creating the list, which is just I. In this case we have I multiplied by 2, but over here the value of I should form the elements of the list provided the condition is true. So you will have I here, okay, just I, and then followed by the looping statement for I in range 1 comma 51, and then comes the condition, okay, and the condition is if I modulus 3 is equal to 0. Alright, so this is the expression used for creating the list, and then you have the for loop which is iterable on this particular object, and then you have the condition, right? The condition is optional. So when you do the actual programming, instead of this, you can just use this. Just have this alone, this lone statement. Okay, but the program will still work correctly. So the order of the execution is going to be like this. First things first, this for loop will be executed. For loop, the value of I will start with 1 and then checks the condition. If the condition is true, the value of I will be assigned to the list, or in other words, I will become the first element of the list. And then again it moves on for the next value of I, which will be 2. If the condition is true, false, based on which the value of I will be assigned as the element of the list. Okay, so example number 2 is nothing but I have just incorporated one condition with if. So, which means there will be a little change in the way you should write the list comprehension. Okay, so it's pretty simple, right? Now let us move on to the third example. Now this time I would like to have the if-else pair. If there is a necessity of if-else in your program, how would you like to have it converted to the program, but using the list comprehension? Now let's take again a very simple example. So this time, if-else condition. Okay, if-else condition with the list comprehension, right? Now let's say the example would be something like this. If the value of num is less than 5, store as it is. Okay? And then if the number is greater or equal to 5, store it as num multiplied by 2. Okay, so the question is pretty simple. The values which are below 5, I would like to keep as it is. The numbers which are equal to 5 or greater than 5, I would like to have it multiplied by 2 and then have it appended to the list. Okay, so let's do the normal way out. It's going to be like this. Let's have an empty list, all right, and then for I in range, and then I'll have 1 till 11. Okay, and then I'll have this colon. Okay, now there you have the condition. If the value of I is less than 5, these are pretty simple, right? I would like to append the numbers as they are. Okay, else if the condition is false, I would like to append the value of I having multiplied by 2. Okay, so I should have used the num variable, but that's all right. So in place of num, I've used the value of I. All right. So this is normally how you write the program for this task. Okay, so if the value of I is less than 5, the value of I as they are will be appended to the list. However, if the condition is false, if the numbers are greater or equal to 5, then they'll be multiplied, and that's how they will be appended to the list. So if you would like to do the same thing again using the list comprehension, it will be something like this. You will have list equals. Now this time you need to watch out properly. Okay, first thing that you are going to write is the statement of if. This is something which you need to keep clearly in your head. If the situation demands the usage of if-else, the first thing that is going to be in the list comprehension is the statement of if. The statement. This is the statement of if. Okay? So the expression for creating the list, if the values of I are less than 5, will be just I. Okay? And then what follows is the if condition. You have if the value of I is less than 5. So this is the statement associated with if. And then you will have else, alright? And then comes the statement associated with else, which is nothing but I multiplied by 2. And then finally you have the for loop, for I in range, and then you have 1, 11. Okay? So this is the statement associated with if condition, and then this is the statement for creating the list, which is associated with this else. Okay? And then finally you will have the for loop. So if the situation demands us to use just one if condition, you could have it here. Okay? Otherwise, if you have this pair of if and else, then you need to have this, picture clear in your mind. The first thing that comes here is the statement associated with if, and then you have else, and then the statement associated with else, and then comes the for loop. So this is again one of the variations in list comprehension. Now the question is, what benefits? What are the advantages? Now this is a very important question. Why do we have this feature unlike in the earlier programming languages? I've learned, quite a bit of programming languages, but I've never ever come across, this particular concept. There are two big advantages. The first advantages is understandably code reduction. Okay, there will be reduced number of codes if you seek the help of the list comprehension. For example, if you could just take a closer look, you'll have how many statements roughly? 1, 2, 3, 4, 5, 6. So in place of 6 statements, you're just going to have one single statement. And then same is the case with example number 1 and example number 2. So if your program has less number of codes, understandably, there will be less problems, to think over. Okay. Now the second big advantage is faster processing of the program. Okay, faster processing of the program, which means the speed with which the program or the software runs or executes will be much faster. So, for example, the reason why I'm saying faster processing is generally whenever you use the append function, let's say the value of I is 1, 1 will be multiplied by 2, 2 will be appended to list. Okay, so this is how the first step is executed. And then when the second value, which is 2 times 2 is 4, there will be a reallocation of memory in the size of the list. And then 4 gets in, and then before the next value of 6 gets in, there will be a reallocation of the memory. So this is a very, very expensive procedure, reallocating the size of the memory. So it takes up a huge amount of the time, huge amount of resource when it comes to allocating a memory, again reallocating the memory. If you face difficulty in trying to digest this fact, it's something like this. Let's say you have a house of this size, okay, and then few more family joins in. It's literally impossible for me to accommodate all of them. So again, I rebuild the house, okay, again some more gets in, and then again if I keep on rebuilding the houses, it's going to be a big problem. So this could be a perfect analogy when I say with the help of functions like append or extend, every time a new value is assigned, there will be a reallocation of memory, which is a very, very expensive operation in terms of computers. But what happens with the list comprehension is all the elements are figured out first. Whatever elements are going to be a part of the list, they are all figured out first, and then the size of the required list is calculated, and then all the elements will be assigned to the list. If I could just repeat it, in the list comprehension, all the elements are first figured out. Okay, in this case, I'll have numbers like 1, 2, 3, 4, and then 5 will be multiplied by 2, that'll be 10. So 1, 2, 3, 4, 10, and then you have 12, 14, 16, okay, it goes on and on, right? So once I have all the numbers finalized, so based on which the allocation of the list, will be done, okay? And then all the elements will be assigned to the list. So which means there is no allocation, reallocation process, being taken place. So, this is again one of the reasons why there will be a faster processing of a program if done with the list comprehension. And then another reason why the program processes faster is, if you look at the list comprehension, there is no function call as such. We have this chapter of function at the very beginning of the textbook, right? So whenever you call a function, what happens? The interpreter, will have to go to another part of the memory, okay, in which there will be a memory allocation. Once the function call is taken care of, again it comes back. Again, for the next append function call, again it goes back. So every time a function is being called, a certain amount of time is being wasted. It goes to the function definition, it executes, it comes back, again it goes back. So for example, in this particular program, the append function is called how many times? 10 times. So 10 times. So when the function calls keep getting stacked up, it will unnecessarily lead to the wastage of time. But what happens with the list comprehension is there is no function call as such. Hence, the program runs faster. So over here, reallocation. Perhaps through this term you'll be able to remember. Reallocation of list is avoided. Okay, this is just my explanation, but if you could look at the textbook, there will be a proper reason. And then it reduces the function overheads. Function call overheads. Overhead means the amount of time which is required time and again to call the function, right? So these are the two reasons why the program runs faster, just in case if you decide to write a program using list comprehension. But on the flip side, if the conditions, if there are just too many conditions, too many, the if and the else statements, then it's not a good idea to be writing the program using list comprehension. It will become very, very complicated to the extent that you will face a lot of difficulty in understanding the program. So that's, on the flip side, you have this disadvantage. So do not ever use list comprehension if there are just too many if or the else statements. Alright? Now let us move on to the next example. Just get rid of this. Okay, in order to understand the list comprehension better, let's come up with the question. Okay, even though you are in no position to give the answers right now, right here, but as a matter of feeling a little confident, let's say I have an example like this. List is equal to, okay, and then you will have the element as tuple, alright, A, and then I'll have 11, you will have B, 12, this is character, right, and then you will have C, and this is going to be 13. Okay, let's take an example of the list in which I have 3 elements, and the type of the elements of this list is nothing but the tuple, right? So I'll come up with a list comprehension. Let's say I have a new list by the name of n list, in which I will have expression like, say, n multiplied by 3. This is supposed to be a question, alright? And then for x n in list, okay? And then if the value of x is equal to b, or the value of x is equal to c, okay? So this is supposed to be a question. Now let's say if I print the value of n list, what will be the result? Okay, so even though this question is meant for you, but unfortunately I'll have to give the answer as well. So again, this is nothing but the list creating expression which is used to create the list, and then you have the for loop, and then you have the condition, right? So this is again an iterable object. The iterable object means object which could be traversed, object whose values could be scanned again and again. That's what we actually call it as iterable. Iterable means something which is repeatable. With each repetition, you could grab onto a certain value. So now this time I'm not using the range function. Okay, so if I just start executing this program, I need to start from here. So for x comma n in list means the first element of list will be assigned to the 2 variables pair of x and n. The first value of list is a and 11. So x will assume the value of a, and n will have the value of 11. Okay, so for the first loop, the value of x will be a, the value of n will be 11. And then the explained, just like how I explained a little moment back, the if statement will be executed. The value of x being a, is it equal to b or is it equal to c, the condition becomes false. Hence, this particular expression will not be assigned to n list since the condition is false. And then, for goes for the next row. Now this time, x will have the value of b, n will have the value of 2. This time, the value of x is indeed equal to b. So, if you have or operate in between, if one of the conditions is true, the overall condition will be true. Okay, so since this is true, this will be false. True or false is true. Now this time the value of n, which is 12, will be multiplied by 3. It becomes the first element of n list, which is going to be 12 times 3 is 36. And then 4 will have the final loop or the final run. X will have c, n will have 13. This condition will be true. Again, the value of n, which is 13, will be multiplied by 3. And 39 becomes the second element of the n list. So perhaps this question could be of worth 1 mark. So the idea is to make you feel a little better when it comes to understanding the list comprehension. Okay? Now let us move on to the next topic. The next topic will be, just rid of this. The next topic will be nested. Okay? Or perhaps, I could just write here 2-dimensional list. Okay? Okay. So what do you mean by nested list is when one list is embedded in another list. Say in a list, if the element is a list in itself, okay, that's what we refer to as nested list. Or in other words, we could actually call it as 2-dimensional list. Now let's come up with the example. Let's say I have list A is equal to, I don't remember the question, so let me just copy from here. Okay, but before this, let me come up with another example. Okay, now let's say I have two lists. The first one is 10, 5, okay, and then say 2, alright, and then B, I'll have values like 2, 3, and 4. Now the question is, I'll have to form another list. I'll have to form another list by the name of C. Okay, so the idea is I have to form the elements of C as every element of A must be raised to every element of B. Say 10 raised to 2 will be 100, okay? 10 raised to 3 will be 1000, 10 raised to 4 will be 10,000, I guess, okay? And then likewise, 5 raised to 2 will be 25, 125, 625, and then finally 2 raised to 2 is 4, 8, and then I have 16. So I have two lists, A and B, and the third list, C, will be formed by raising each element of A to every element of B. So generally how do I do is, okay, I'll just use the for x in, this is the common way to write the program for this particular task, okay, and then for y in B, okay. Let's just get rid of this for y. Okay, this is nothing to do with the two-to list as of now. Okay, and then C dot append. Okay, so this is the new list to be created, remember? And then the expression for creating the list will be you will have x and then two asterisks. That two asterisks represents the exponent. Remember, exponential operator. Okay, and then you will have the y. Right? So you have this simple program, which will create the required list. If I could quickly trace the program, the first value of x will be 10. Okay, the first value of y will be 2. X traverses in A, Y traverses in B. The first value of X will be 10. The first value of Y will be 2. So the first element will be 10 raised to 2, which will be 100. Okay? And then it goes for the next value of Y. I need to finish all the inner loops. Remember, the next value of Y will be 3. But the value of X will still be 10. So 10 raised to 3 will be 1000, right? And then y will again go for the next value. So when I'm done with all the possible values of y as 2, 3, 4, x will pick up the next element in the A, which is 5. So again 5 raised to 2, 5 raised to 3, 5 raised to 4, so on and so forth. So this is not the task. I need to have this converted into the list comprehension list, right? So how do you do it is list is equal to, so again you have this expression x exponent y exponential operator, and then you have 4x in A, okay, and then you have 4y in B. Alright, so that's it, I guess. Again, this is the expression for creating the list. You have the first loop, the outer loop, and then you will have the inner loop. Okay, so this program, which has 3 statements, could be replicated logically using the list comprehension like this. You have the expression, you have the outer loop, and then you have the inner loop. Now, since I don't have any condition as such, I don't need to include any condition, right? So this is how you take care of the program which involves a nested loop. Okay, this is something to do with the nested loop. One loop embedded in another loop. That thing which I wrote here was meant for the next topic. Okay. Now let us take another example. The second example could be something like this. Let's say I would like to pair up even numbers with odd numbers. The question is, don't worry, in the exam the questions will be crystal clear. So as of now, in order to reduce the duration of the video, let me orally cite the question. It is, I would like to pair up the even number with odd till 10 starting from 1. So which means from 1 to 10, if I could pair up the numbers, it will be something like this. Even number, say let's not drag it till 10, there will be just too many. So let's keep it till 5. Even number has to be paired with odd. So the new list will look something like this. 2, 1, 2, 3, okay, and then 2, 5. Since I said the limit will be 5, I would like to stop at 5. So this is the even number. Each even number has to be paired up with every odd numbers. And then the next, since with 5 I'm done, I've reached the limit. So the next even number will be 4, 1, okay, 4, 3, and then you have 4, 5, okay. So the question is, each even number has to be paired with every odd numbers. So I guess these are the possible combination. So if I could write the program in a normal way, it's pretty simple. For I in say range, and then I'll just write 1, 2, 6. Okay, these are nothing new. And then I check this condition. If the value of I modulus 2 is equal to 0, only then I need to proceed further. If the first number doesn't satisfy this condition, then you're not supposed to go further, because that means that number is not even, right? So when a number is divisible by 2, and if the remainder comes out to 0, that number is even. So if the condition is true, then I have the inner loop, which is for j in range, and then you have 1, 6. Now the question is, should I be including I, j pair in the new list? Again, I have one more condition. The condition is, if j modulus 2 is equal to 1, then I have to form the pair. Right? So it's going to be something like this. Oh, the name of the list is C. All right, C dot append. Okay. And then I write here ij. However, if you just keep the parameters like I, j, it means the append is expected to receive 2 parameters or 2 arguments. This is a mistake, because the append function is designed so that it should receive just 1 parameter. But the problem here is I have 2 parameters. So in order to take care of this program, you could have another pair of brace or bracket. Now this ij pair will be treated as a single parameter. If you just leave it like this, you are assigning or you are supplying 2 arguments or 2 parameters. Okay, so make sure that you have additional pair, just to indicate that this ij are not 2 separate values, rather they are a part of a single argument. Okay, so Now the question is, how do I do this? Do the same thing using the list comprehension is, just get rid of this. Okay, this is fairly simple. You will have C is equal to, okay, you will have X comma Y. Okay, X comma Y. So again, this bracket is so important, alright? And then comes the first outer loop, which is for I in range of 1 to 6. Okay? And then comes the condition. If I modulus 2 is equal to 0. And then you have the next condition here, for j in range of 1 comma 6. And then finally you will have the condition associated with j loop. If j modulus 2 is equal to 1. Okay? So this is how you comprehend. This is how you shorten. This is how you provide the shorthand method for creating the list, for this particular program. So imagine, you have how many lines? 5 lines, which are summarized inside just one line in the form of single statement. So that's the whole idea behind the list comprehension. So this is the first for loop which will be executed. I will have the value of 1. 1 modulus 2 is equal to 0, the condition is false. So it doesn't go any further. And then again, I will have the next value of 2, the condition is true. Okay, 2 modulus 2 is equal to 0. J will have the first value of 1. 1 modulus 2, the remainder is indeed 1. Okay, so many of you do get confused. 1 modulus 2, how come it's equal to another 1? If I could just show you, okay, so it cannot be 2 times 1, rather it has to be 2 times 0. 2 times 0 is 0, 1 minus 0 is 1. So whenever you divide 1 by 2, the remainder will always, become 1. But I'm strictly speaking in terms of integers, right? So with this, I've given you enough examples with regard to the list comprehension. The first 3 examples were straightforward. They have just one loop, but the later 2 examples, this and this particular examples, they were to do with implementing, the list comprehension for a program which demands the usage of the nested loop. Okay, so we'll try to come up with a question again. In order to understand the program a little better, just get rid of this. Okay, let me just take a look at the example. Alright, let's say you have LA is equal to 11 and then oops, this is 22, 11. You have list B as 33, 11. You have LC as 11, 14, 11, 14, and LB, if I'm not wrong. And then LX is equal to 11, LA, LB, and then finally I have 15. Okay? Okay, now this is with regard to the nested, okay? The nested or 2D list in Python. Okay, so this is not a 2D list as such, but LC and LX are examples of nested list, because this particular element is nothing but a list. So you have a case, you have a clear case of list being the element of another list, that's nothing but nested or 2D list. And then LX is very much nested or 2D list, two-dimensional list, because you have the elements as LA and LB, which are nothing but list in itself. Okay, so now the idea is I want to know how to get to a particular element using the list index. Now let's say if I print something like this, LX of 1. If I print the LX of 1, what will be the answer? These are pretty straightforward, but just to play safe. So you have index lined up like this. This is 0, this is 1, this is 2, this is 3. So if I could just print out the LX, if I print LX, it will be something like this. 11, the LA will form the second element. Okay, second element. LA is nothing but 22, and then you have 11. LB will be 33, 33, 11. Is it? Okay, I think. Okay, sorry. This is LC. This is LC. If it were to be LC, the question is a little complicated. Okay, LC means you have 11, you have 14, but LB again has 33, 11. Okay, and then finally I'll have 15. Oh, sorry, right? I'll have 15, right? So basically, if you print the content of LX, you will see something like this. So 11, comes right here. This is what LA represents. This as a whole is what LC represents. But in LC, I have the LB. So LB will have 33, 11, and then finally you have the 15. So LX 1 will point to. So this will be the index of 0. Okay, this is index 0, and this will be 1, this will be 2, and then finally this will be 3. So if I try to print LX of 1, I'll get the answer of 22 and 11. Okay, and then likewise, if I print the value of LX of 2, I'll get this entire thing. I'll have 14 and then 33 and then 11. So this is the second element as a whole of the list of LX. So likewise, if I have something like this, LX of 1 and 1. 1 and 1 means I need to first refer to the first element of LX. The first element of LX is this. So from this, pick up the element with index 1. So 22 will have the index of 0 and 11 will have the index of 1. So this is how you refer to the nested list or 2D list. Once again, you need to first focus on the whole elements of LX. So LX1 means 0, 1, 2, 3. You're referring to this. And then the second, the index is referring to the elements within that particular list. So within the first element with the index of 1, you have 22 and 11. So this will be 0 and this will be 1. So this is how you get 11. Alright. So let's pick up another example. Let's say you have LX of 2 and then 1. So LX of 2 means 0, 1, 2. 0, 1, 2. Out of which pick up, the 1. Pick up the 1, right? So you have here 2 of 0 means 0, 1, 2. And then pick up the first one, that's going to be the 14. Okay? Did I get it right? Let me just check. 14. Okay. Okay, fine. So you have here 14. Alright? The examples were a little different. And then perhaps we'll go, say if you want to refer to this, if you want to refer to this, how would you write, the list element? It is something like this, LX, okay? First get to this particular point, which will be 2. I need to refer to this, okay? And then, once I reach here, I need to reach this. Now this is the third element or the element with the index of 2, okay? So how do I reach here? 0, 1, 2. And then I write here 2. And then finally, how do I reach here? So within this, again, you have 0 and 1. So which means you will write here 1. So LX of 2 means 0, 1, 2. And then from this particular element, I go for the second indexed element. Second indexed element means 0, 1, 2. And then once I reach here, I pick up the element with index number 1. So this is going to be 0 and 1. So this is how I actually refer to the nested list or to the list. So you need to keep using the index number in order to point to a specific position. Okay?